Hey you all, my name is Jack Hoskins Harris and I'm a rising senior here at the University of Richmond. I'm a chemistry major, so I'm really glad to be able to pursue chemistry in a research lab just like this here at U of R, thanks to the Richmond Guarantee. It's really easy to get involved in a lab. All I did was take a few introductory chemistry classes my first and second year here, talk to some professors, get an idea of what their research was, and I was able to have a good conversation with one of them, and that's the lab I ended up in, where I now get to do organic and inorganic chemistry right here with Dr. Miles Johnson, a Richmond alum. Over the past 2 years, I've been doing this research, and I've actually been published as of January of this year. My research is mostly on one catalyst in particular. It's called a proazophosphotrain. Most people call it Vercade's base. It hasn't really been studied that well, but I was able to discover that this specific catalyst actually speeds up certain reactions that people didn't really expect, and because of that, we were able to publish that paper. And now this summer, I'm here doing a follow-up research project on a potential other reaction that it should speed up as well. Hopefully, the research that I'm doing will have implications for both pharmaceutical design as well as manufacturing.
For this procedure, I need to bring in these two solid chemicals into the glove box, but it's really important I don't introduce any oxygen when I do so. So both oxygen in the air as well as water must be removed. To do that, I essentially attach a powerful vacuum to a hot glass container. This allows me to suck out all the air inside, including the oxygen, leaving just the solids behind. Additionally, these solids have the tendency to sublime, which is when a solid skips its liquid phase and instead turns right into a gas under various circumstances. Before I start though, I need to get some liquid nitrogen. We don't want any of this potential gas to be sucked into the pump because then there's the chance that we would have to breathe it in the lab. So we use a liquid nitrogen trap to ensure that any gas is condensed due to the very low temperature of around negative 196 Celsius, which is right around negative 321 degrees Fahrenheit. Once the gauge at the top right says that we're at a very low pressure, we're good to transfer into the box since there is little to no oxygen present at this point. So this is one of our glove boxes that we have in Johnson's lab here. We actually have two different ones, and essentially it's just an airtight container that we can go in through these rubber gloves so that we can do all of our reactions under just the nitrogen atmosphere. The reason we have these is that a lot of us use chemicals that are super reactive with oxygen. So we have to do all of our manipulation right here in the box so that they don't react with oxygen, which could then cause them to degrade, break down, or change their identity. And then to bring anything in, we have to put them in this special antechamber right here, where essentially you put it in and then turn this valve and it sucks out all the air inside, and you can refill it with nitrogen, and then that way you can bring it into the box. A great example of a skill I've learned through research is how to take and analyze an NMR, which stands for nuclear magnetic resonance. This is basically a technique that creates an electric field that affects the nucleus of an atom at various frequencies. This allows us to determine the structure of the molecule we're looking at. I use the NMR currently to monitor my reactions to see if my expected product is being produced or not.
Hi, my name is Paige. I'm one of Jack's friends. I'm also in the Johnson lab with him. As you can see right now, I'm using the rotary evaporator, or we call it rotovapping for short. And essentially what this does is I have my flask full of what I hope is pure product, because that's my goal, of course. And we put it down in this heat bath, and it essentially removes all the extra solvent. Once the other solvent evaporates, it goes up through this bump trap, which is this other glass piece, goes up into here, into our cold finger. This we fill with dry ice each and every time, which is super fun. And there's also isopropanol in there, and it causes this gas to condense, forms a liquid, as if you can see here, it's dripping down, drips into this bowl. At the end of every use, we dump this out, and that's really it.
I'm Sylvia. I'm also in Dr. Johnson's lab, and right now I'm doing a column, as you can see, which basically I do to remove any impurities from my product after I've already run the reaction. And the idea is that you push solvent over your product, and the more polar your impurities or your product is, the more polar things will go down first. And so we put it into different test tubes, and then we see which test tubes have the same stuff in them and combine them and hope that the impurity is out.
For lunch, me and my friends like to walk over to Passport Cafe, which is in the Carol Weinstein International Center, where we like to sit outside in the courtyard and enjoy some nice lunch food.
All right, I got the turkey caprese sandwich right here and peach vibe Celsius.
So I decided to go with a drink, one of my favorites actually, strawberry mango green tea Palmer, super refreshing in the summer.
Also went with the gazpacho, having a weekly lunch special. Figured I'd try it. Final thing I got, classic roast beef panini. Doesn't get better than that.
All right, and for me, I got the chicken bacon sandwich. It's delicious. And I also got the Passport Palmer, which is a big favorite here at Passport. Well, that about sums up a typical day as a research student over the summer here at the University of Richmond. There's a lot of stuff to do. You're in lab for part of the day, you're having fun for the rest, and it's a really great community. You get to hang out with all your friends, have a great time. So I highly recommend it, and I hope that you all enjoyed watching this video. So thanks for watching.